This is lesson 2 on sequences and series. This lesson we're focusing on arithmetic sequences or arithmetic sequences. And remember the difference between an arithmetic sequence and a geometric sequence was in an arithmetic sequence the difference is you're adding a constant term each time. So you're either adding a positive or a negative term to the next numbers rather than multiplying or dividing the difference. So an example of that is this sequence given to us here, 7, 10, 13, 16. So each term is determined by adding, well, to get from 7 to 10 you have to add 3, to get from 13 from 10 you have to add 3. So we're adding 3 to the previous term, where 7, 10, 13, and 16 are all terms. So in order to calculate the differences, all you need to do is take your term 2 and you subtract term 1. So what that means is you take 10, which is term 2, and you subtract 7, which would be term 1. So T2 minus T1 ends up being 10 minus 7, which is equal to 3. T3, which was 13, subtract T2, or term 2, which was 10, would give you term 3 minus term 2, which would be 13 minus 10, also equal to 3. And then we would do the same thing for the fourth term and the third term, fourth term being 16, third term being 13, which would be 16 minus 13, and we would end up with 3 again. So the difference between all of these sets of terms, all the successive terms, the terms that come one after the other, the common difference is going to be 3, and that would be an arithmetic sequence. Now, sometimes, well, we just kind of looked at how to find the common difference. But in order to find the common difference, you're just using that basic formula, T2 minus T1, T5 minus T4. Whatever successive terms you have, you subtract the next term from the previous term. And so the actual formula for that, for the common difference, is Tn minus Tn minus 1. So this is one term. So we'll look at how this works. So if we look at these values, consider the sequence 16, 13, 10, and 7. Well, remember, this is term 1, this is term 2, this is term 3, and this is term 4. So in order to find the common difference, we need to use our formula Tn minus Tn minus 1. So Tn is going to end up being term 2 minus term 2 minus 1, which in this case, since n is 2 in this case is going to be term 1. So this becomes T2 minus T1. So we look at what T2 is. T2, and I'll just jump up here, T2 is 13 and term 1 was 16. So 13 subtract 16, we're going to get negative 3. And we do that for each successive term as well. And so in order to make sure it's an arithmetic sequence, we have to do it for a number of terms if it's not obvious that the difference is going to be a constant positive or negative term. So we'll move on to term 3 minus term 2, which will give us 10 minus 13, also gives us negative 3. And term 4 minus term 3, which would give us 7 minus 10. Again, our common difference is going to be the same, so we have an arithmetic sequence. So our constant difference here, our common difference is going to be negative 3. So next we want to find, in class example number 2, we want to determine which of these sequences are arithmetic, and then find the common difference for those which are arithmetic. So if we look at A, 2, 4, 6, 8, right away we know that's arithmetic because there's a common difference. Every time I go to the next term, I'm adding 2. So we'll say that's arithmetic. The common difference is equal to 2. For B, 1/2, 1/4, 1/8, 1/16. So this is, even though if we were to just look at the denominators, it looks like it is arithmetic. It goes 2, 4. Well, and we actually miss some. So every time we are multiplying the next term, and so this is not going to be arithmetic. It doesn't increase by a common constant term, by a positive common constant term. Next we have C, -10, -4, 2, 8. Well, if we were to plug it into our formula, Tn minus Tn minus 1, where we take our second term, which is going to be -4, and we subtract -10. We end up getting a common difference of 6, and we're going to have that in the next terms as well. And so this one is arithmetic. The common difference here is equal to 6. And for D, 4, 8, 16, 32, well, to get from 4 to 8, you can either add 4 or multiply by 2. And let's see, to get to the next term, 8 to 16, you have to multiply by 2. So we're multiplying each successive term, which means it is not arithmetic. So the only two that were A and C. A lot of times you'll see this guy, and he's just telling you to stop and read these phrases because they are very helpful. So in an arithmetic sequence, we often use the terminology. The first term in an arithmetic sequence is represented by T1, which we used up here and at the beginning, or the value A. Okay? So T1, or we have the variable A, and the common difference is represented by D. So we have variable D being the common difference, D for difference, and then T1 or A for our first term. So in this next example, what they want us to do is find out what A and D are in the following sequences. So A, remember, all that means A is term 1 or T1. So the first term, which would be -8. And our difference, if I go from -8 to 2 and from 2 to 12, then my difference is going to be 10. And again, we can solve that easily by plugging into our formula, Tn minus 1, or term 2 minus term 2 minus 1, which would be term 1. And then that would give us 2 subtract -8, or 2 plus 8, and we're at 10. So our common difference is 10. For the next one, our first term, our value of A is going to be 15. And then our common difference, well, remember, in order to find our difference, we can use our common difference formula, Tn minus 1. And so that becomes T2 minus T1. Our common difference is going to be 10 minus 15, which is going to give us a difference of -5. So let's look at this investigation. And this investigation is going to lead us to another formula that we use for arithmetic sequences. And so consider the sequence 2, 12, 22, 32, 42, and state the following: term 1, term 2, term 3, term 4, term 5, and then the first term and the difference. So we know that term 1 is 2, term 2 is 12, and then we're going to just follow this sequence. My first term was 2, and the common difference, well, between 2 and 12, that's going to be 10. Between 12 and 22 is going to be 10, and it's going to be 10 each time. So complete the following pattern, which describes each term in the sequence in terms of the first term A and the common difference D. So they've started the question for us in order to show us how this pattern works, how the sequence works. So I started with 2, and my first term T1 is equal to A. That's all it's telling me. term 2 is equal to 2 plus 1 times 10, which is equal to 12. Term 4 is going to be 2 plus 3 times 10. So 3 times 10 is 30, plus 2 is equal to 32, which gives me term 4. So term 4 is equal to a plus 3 times d. Term 5, 2 plus 4 times 10 is equal to 42. 4 times 10 is 40, plus 2 is 42. And my fifth term, or term 5, is going to be a plus 4d. So this is just a different way to write our sequence out. So we're still getting the same values that we had at the beginning. For term 30, well, if we see what the sequence is right here, so with my fifth term, I went 2 plus 4 times 10. For my fourth term, I went 2 plus 3 times 10. So for my 30th term, I'm going to go 2 plus the previous number before 30, because that's what I did before, right? 4 was before 5, 3 was before 4. So this is going to be 2 plus 29 times 10, which is going to be equal to 29 times 10 is 290, plus 2 is 292. So my 30th term is going to end up being a plus 29 multiplied by the difference, 29d. And so my common, or my actual formula and pattern that's going to develop here for any nth term, for Tn, if I want to find any nth term, is going to be 2 plus n minus 1. So the previous term before this n value multiplied by, in this case, 10. And so for any Tnth term, we could also say that's a plus a being the first term, n minus 1, and multiplied by 10, which was my difference. This is the formula that you're going to end up using all the time for determining an arithmetic sequence. So that brings us to this next section. So the formula for the general term of an arithmetic sequence is given here or here. So the way you read this is Tn is equal to T1 plus n minus 1 times d, or Tn is equal to a plus n minus 1 multiplied by d. So these are the exact same formula. The only difference is this one uses the terminology of T1, and this one uses the terminology of a to represent the first term. So Tn is the general term. So that'll give you any term you're looking for. Like if you want to look at, in this example, for like the 1032nd term, then you would use this exact formula here. A is the first term in the sequence, D is your common difference, and then N is the position of the term in the sequence you're looking for. Now let's try to apply this formula. If we look at class example number 4, consider the sequence -6, -1, 4, and 9. And we're told it's arithmetic, so yeah, we know exactly which formula we need to use and how the sequence is actually going to work. So determine the formula for the general term of the sequence. Well, we already have our first term, the value of a, which is -6, or if you would like, you could say that's the value of T1, term 1. And we have our difference if we have 4 consecutive terms. So remember, in order to determine what your difference is, all you need to do is plug in this formula, T2 minus T1, and that gives you your difference. So term 2 was -1, and term 1 was -6. So we end up getting -1 subtract -6, or -1 plus 6. Our difference is going to be 5. The next thing we want to do is determine the formula for the general term of the sequence. So the formula, our general formula anyways, is the one we determined earlier on. So Tn, that gives me, remember Tn is any term, any general term, a plus n minus 1 multiplied by my difference. A being negative 6 plus n minus 1. I'm not sure what n is, right? Because that's any nth term. Multiplied by 5, my difference. So negative 6, and if we distribute this 5 into the brackets, we're going to be left with 5n. Distribute that into the negative 1. Negative 1 times 5 is negative 5. And then I simplify my like terms. So negative 6 and negative 5 are like terms. They have no n, so I'm left with 5n subtract 11. All right, and that's your general term for the sequence. Next, determine the value of the 12th term of the sequence. So if I want to determine what the 12th term is, I just plug it into this formula. So T12 is going to be 5 times 12 minus 11. 5 times 12 is 60, subtract 11, we're left with 49. Alright, so for this next question, we're doing the exact same thing. The only difference, however, is that we're given this value here, negative 117. But we begin the same way as we did before with our first term, which is 3. Our difference, negative 1, subtract 3, our difference is going to be negative 4. And we're given the value of Tn this time, which is our last term in this case, and that's negative 117. Now, we're going to use the exact same formula that we used before. So Tn is equal to A plus n minus 1 multiplied by the difference, G. Tn is equal to negative 117. So we have the variables laid out at the beginning, which we should do in every question. And now we need to insert them into the formula that we're going to use. So Tn is equal to negative 117. A is equal to 3 plus n minus 1 multiplied by the difference, which in this case is negative 4. Now from here I simplify. So I distribute my negative 4 into my brackets. So negative 4 times n is going to give me negative 4n. And negative 4 times negative 1 is going to give me positive 4. Negative 117. If I simplify my like terms now, 3 and 4, both positive, are going to give me 7 minus 4n. Now, still not completely simplified. Now, one way that's easy to do this is if we just bring our negative, because we have a variable here, bring the negative 4n to the other side, which will give us positive 4n, and this negative 117 over here, which will give us positive 117. And running out of space, I'll move up here. 4n then is equal to 7 plus 117, which is going to be 124. Now we need to divide both sides by 4. N is going to give us, 4 goes in 12 3 times, it goes in the 4 once, 31. So in this sequence, we were looking for the number of terms. And it turns out there are 31 terms in this sequence. Next, we're looking at arithmetic means. So all an arithmetic means is if I have, let's say, 2, 4, 6, 8. And let's say in this sequence, they didn't give me the 2 middle terms. So arithmetic means, that means that these 2 and 8, my first and last terms, end up being kind of the bookends of the sequence. These 2 terms that don't exist, or well, they exist, they're just not given to me, they're unknown, those are my arithmetic means. So what we want to do is place 3 arithmetic means between negative 4 and 8. So I have negative 4, and then 1, 2, 3 arithmetic means, and 8. So what I want to do is I place those 3 means between my values, and now I need to determine what they are. So I know that my my first term, my value of a is negative 4, and I know what my last term is too, so 1, 2, 3, 4, 5. My last term happens to be term 5, and that's equal to 8. So if I solve, we're going to be using the same formula. Tn is equal to a plus n minus 1 times d. And the term we were given is the fifth term. And if we're using the fifth term, n minus 1, n being 5, so 5 minus 1 would give us 4d. We don't know what the difference is yet, and that's what we're trying to solve for. So t5 was equal to 8. A was equal to negative 4 plus 4d. Now I need to combine my like terms. Bring the negative 4 to the other side gives me 12 is equal to 4d. And divide both sides by 4. My value of d gives me 3. So that's my difference, which means I can add my difference to everything else. So negative 4 plus 3 is going to give me negative 1. Negative 1 plus 3 is going to give me 2, and 2 plus 3 is going to give me 5. So remember, if I'm going too fast, just pause anytime and go back.